Okay, so still on the displacement velocity acceleration sheet, we have number 16 and 17 to go. Okay, so number 16 says, the drivers of two cars in a demolition derby are at rest 100 meters apart. They begin to head towards each other. They are both accelerating at a constant 2.5 meters per second squared. How long before they collide? Okay, so we have one car here going this way, and one car over here going this way. And we know the distance between them is 100 meters. Okay, what are our two parts? The two cars. They're both at rest initially, so VI is 0 and VI is 0. They both accelerate at a rate of 2.5 meters per second squared. And the question wants to know how long before they collide. So if they start at the same time and they end up at the same spot in the middle, whatever their time is, it's going to be the same thing, right? Because you and somebody else can't start moving at the same time, collide with each other, and one of you move a longer period. Now, and in this one, I think you know what the delta D will be. Because of the 100 meters, and because their accelerations are the same, their delta D should both be 50 meters. But if their accelerations were different, that wouldn't be true. Instead, what would be true would be that delta D1 plus delta D2 would equal 100 meters. So I'm going to do it as if the two A's aren't the same, just to show you how you would if they were different. So delta D1 we wouldn't know, but we would know it's equal to VI delta T plus 1/2 A1 delta T squared. Agreed? Because we could find it with the givens. And the VI is 0. So our delta D1 would be 1/2 A delta T squared. But the problem is I can't find this because I don't know the time and I don't know D1. I have two unknowns. And if I have two unknowns, it means I need two equations. So if I go over here, I could do the same thing for delta D2, VI delta T plus 1/2 A delta T squared. The VI is 0. So D2 is equal to 1/2 A2 delta T squared. And again, just like in the delta D1 equation, in the delta D2 equation, I have two unknowns. Now I know you're saying, but I know D2, it's 50. That's right, in this case it is, but they won't always be the same. Technically then I really have three unknowns. I don't know D1, I don't know T, and I don't know D2. And if I have three unknowns, to solve it, I need three equations. And look, I have three equations. So just like in math, when you're doing like X and Y, I'm going to sub in where my D1 is, I'm going to sub in 1/2 A1 delta T squared. And where my D2 is, I'm going to sub in plus 1/2 A2 delta T squared is equal to 100 meters. Some of you might want to get rid of the 1/2, and if you do, then it would be A1 T squared plus A2 T squared is equal to 200 meters. So I just multiplied everything by 2. So now I'm trying to solve for T squared, and it's in two different terms, and I'm going to use that cool little trick that we learned when we were doing the math review. I'm going to pull my T squared out. And when I take it out of the first term, I'm left with A1. And when I take it out of the second term, I'm left with A2. And that's going to be equal to 200 meters. And now what do I do to get the T squared alone? I divide by the bracket. So it'll be 200 meters over A1 plus A2. So 200 meters over 2.5 meters per second squared plus 2.5 meters per second squared. In other words, 200 meters over 5 meters per second squared. 5 goes into 200 40 times, and that's T squared. So then you have to take the square root, and you get delta T equals 6.3246 seconds. Way more significant digits, more decimals than we have significant digits. Now, if you had done it the other way, if you had said, I know my delta D is 50, so I'm just going to rearrange this 1/2 a delta t squared for t squared, then it would be t squared is equal to 2 times delta D over A. T squared will equal to, and we know that it should be 50 because the A's are the same, over 2.5 meters per second squared. That gives me 100 over 2.5, which is 40. Take the square root, and lo and behold, we get 6.3246 seconds. Now you're all saying, well, can't we do it that way? You can if the two if everything's the same, if the VI's are the same and the accelerations are the same, but if they are not the same, then you have to do it the long way. So I wanted to show you the long way. All right, one more to go. Number 17. Two trains hitting straight towards each other on the same track, 250 meters apart. Their engineers see each other and hit the brakes. The express, so one part of this question is the express train, is hitting west, and its velocity is 96 kilometers per hour. Okay? It slows down at a rate of 4 meters per second squared, so negative 4 meters per second squared is its acceleration. Okay? That's the express. The flyer is traveling 110 kilometers per hour, and it slows down at a rate of negative 3 meters per second squared. Will they collide? Well, they're going to slow down hopefully until they stop. And will they collide? We know that the distance between them is 250 meters. So you can find how far did each travel, add them up, and if it's bigger than 250, they collided. If it's less, they didn't. So 96 is 26.6 repeating. You do have to change these to meters per second. And 110, I think, is 30.5 repeating. What equation are we going to use? You're looking for the delta D's. Hopefully you're saying VF squared is equal to VI squared plus 2A delta D. So delta D is equal to VF squared minus VI squared over 2A. So the delta D of the express, the F is 0, so negative brackets 26.6 repeating squared over 2 times negative 4. And of course the negatives are going to cancel out. And you'll end up with the express, I think it's 88.8 repeating meters. Same equation for the flyer. The VI cancels again. And so delta D will be equal to, I canceled the wrong one, excuse me, the VF cancels, the VI stays, minus VI squared over 2A. So delta D is equal to 30.5 repeating squared, oops, don't lose the negative, 2 times negative 3. Assuming you don't lose anything like I almost did, you get for the express 155.607 meters. Okay, did they collide? You have to add them together. So delta D total equals the express plus the flyer, and when you add them together, you get a delta D total of 244.496, I think, if you don't round at all, meters. Did they collide? Well, they were 250 meters apart, so they don't collide. They end up being about 5 meters apart. They don't collide, but you're probably going to have to call the paramedics because probably the two conductors, the engineers in the front of the train, probably suffered cardiac arrest if they ended up just 5 meters apart. They were probably panicking. Okay, so those are the homework questions from Wednesday evening. Now I would like you to do the homework questions that I have listed on the sheet for you. Okay?